Hello, my dear students. This is Prof.Vegi from the Department of Chemistry, the University of Dodoma. So, in the previous class, we discussed about the introduction and principles of atomic spectroscopies, and also we have seen the general instrumentation. When you see the general instrumentation for all the three instruments, we have common parts: flames, nebulizer burner system, monochromator, detector, and finally display. And in addition to these five parts, common five parts, there is also resonance line source in the case of atomic absorption spectrometer and atomic fluorescence spectrometer. So today we are going to learn about flames. So by the end of today's concept, you will be able to explain different types of flames that can be used in atomic absorption, atomic emission, and atomic fluorescence spectrometers. In all these three instruments, the flames are common. So here, in order to achieve these objectives, you need to have these following resources: notebook, pen, and pencil. Question about the cooking at home. How you are cooking at home? By using a flame. Where does the flame comes? It is produced by using a gas. So there is a gas cylinder connected to burner, and from where that flame is coming. And what is that gas and how it is working? What makes the flame used in these instruments different from the flame used at home? By explaining all these things, you write a, a paragraph and submit it to me in the next class. So now let us see what are the flames and flame compositions. Actually, in these instruments, the flame is produced by two types of gases. One gas is called as fuel gas, other gas is called as oxidant gas. The combination of fuel gas and oxidant gas produces a flame with very high temperature. The very high temperature is very important in order to efficiently atomize the solution. So, the sensitivity and accuracy of the result mainly depends on the temperature of the flame. So, that's why we have different options in order to produce the flame. Those are fuel gas, there are three options: acetylene, hydrogen, and propane. For oxidant gas, we have air, nitrous oxide. That means we have six combinations: acetylene, air, acetylene, nitrous oxide, air, hydrogen, nitrous oxide, propane, air, propane, and nitrous oxide. There are totally six combinations, 3 times 2, that is six combinations, out of which acetylene and nitrous oxide is having very high temperature. You can see this is the maximum acetylene nitrous oxide combination. So this is useful for the analysis of certain elements which are very strong and stable, such as vanadium and zirconium can be analyzed by using this combination of the fuel gas and oxidant gas. For example, if it is mercury, we don't need high temperature. At room temperature, mercury becomes atoms. That means we have another technique called as cold vapor technique, which I am going to teach in the subsequent classes. These are real flame parts. If you see here, this is the waistline, and here there is capillary tube which will be inserted into the sample, and sample will be going from here. And this is a mixing chamber. I am going to explain that part in the next class. And here, from this, actually here the sample will be converted into aerosol. In the form of aerosol, it is taken to burner head. You can see this is burner head, where you can see there is a burner slot. The flame will be produced through burner slot. So these are the real flame parts which you can observe. Now I am giving you certain activities based on the concept which I explained. What are the activities? Prepare a comparative analysis table which flame fits where, and also how to troubleshoot the flame. So you need to explore these two things and write on a notebook and submit it to me in the next class. So I'm asking you certain questions. You try to answer. List the three main flame types commonly used in these instruments: atomic absorption, atomic emission, and atomic fluorescence spectrometer. Identify which flame produces a higher temperature. Explain why flame temperature is important in atomic spectroscopy. In AS, if an element show lower absorbance using air acetylene flame, what adjustment can be made to improve sensitivity? Answer all these questions and submit it to me. This marks the end of this lesson. In the next lesson, you will learn more details about nebulizer burner system. Already in the general instrumentation, I told you the purpose of nebulizer burner system. It will take the sample to the flame and how it works and what are the different types of nebulizer burners. I am going to explain to you in the next class. Thank you.